Hi, this is our third video sort of in the sequence of trying to figure out what's going on with trigonometric trig ratios for angles that are positive but beyond 90 or negative, right? So what do we do when we have angles bigger than 90 and negative angles, and how do we get trig ratios for that? So you're going to be able to figure out if the trig ratio is positive or negative, hopefully by the end of this, and understand a little bit more, because this is the question we were looking at. We can have things like cosine 30 is 0.866. That should make sense in a way. If I'm doing the cosine of a 30-degree angle, it can fit in a right triangle, and it just means that the adjacent to the hypotenuse is 0.866 to 1. So I could, if I wanted to, could be the adjacent side right here is 0.866, and my hypotenuse is 1. But the question was, how do we put an angle of 150 degrees into a right triangle to figure out adjacent and hypotenuse? Can't do 210, can't do negative 30. What do those things mean? So those are the big questions. Our ratios come from right triangles. What does it mean when we have angles bigger than 90 and negative angles? So one of the ways to think about this that mathematicians have come up with, and that is not what I wanted. All right, so let's say that we have this angle right here. Okay, so here's our angle. It's this guy. It's this guy right here, going out at some theta. Okay, we can pick a point on that line that creates that angle. So here's our point, and that point, now it's looking a little messy, so let's clean this up. Okay, that point we could call x, y. And if that's true, if this is the point xy right here, then this length right here is the x coordinate, and this length right here is the y coordinate. And then our hypotenuse we could find by doing x squared plus y squared is r squared, but there's some length, that's some distance. So given that, if you look at this picture, you should be able to pause the video. We're actually not going to do tangent, but we're going to think about sine and cosine. Given this picture, how would you find the sine for angle theta? How would you find the cosine? Pause the video and try. Welcome back. Hopefully you saw sine was the opposite over the hypotenuse, and you got y over r. And then the cosine is the adjacent, which is down here, over the hypotenuse, and you got x over r. So those are some ways we can think about sine and cosine in the coordinate plane. It depends on our x coordinate and our y coordinate. And in fact, it works even when we're outside of the first quadrant. Let's say I get an angle bigger than 90. Right, so there's my angle right there, okay? I can still pick some point, xy, and if this is theta, this is what we call theta reference down here. And again, I can draw that right triangle, and the sines and cosines, and this would still be our r, are still going to depend on the x and y coordinate. In fact, let's look at it a little more specifically with our 30-degree angle right here, right? So cosine 30 is this. If I go to this, we're going to call this a unit circle. So instead of r, I am going to make the, so we're going to call this the unit circle, because I'm making a radius of 1, which means my hypotenuse, no matter where I go, is going to be 1. So when I have 30 degrees, this is 0.866, because cosine of 30 is 0.866 over 1, 0.866. Now let's look at the next one on our list, 150 degrees. All right, I can draw that angle in standard position. It would start here, right here, and I'd go around and go around until I hit to 150 degrees, which is right there. So there's my theta, okay? But now if I think about my reference angle, what's the reference angle for this? Well, it is also 30 degrees, right down there. And I can make that triangle right here. And it probably looks that way, but I can show you hopefully. If I look at this, if I take this triangle and I flip it, boom, and I move it over. Oops, don't want to move the circle. I want to move the triangle, right? Can you see that that looks like that should be the same size, right? So I'm going to undo that, which means that when this side right here was 0.866, this side right here should also be 0.866 because my radius, which is the hypotenuse on the circle, is still 1. And the ratio, the cosine ratio for 30 degrees should be 0.866 over 1, which when I come back here, it says 0.866. Oh, but it says negative. Why would this be negative? Think about it. I want the x coordinate. This way right here is actually a negative x coordinate, and I should get a negative cosine ratio. So that should make sense. All right, let's try another one. So cosine 210. Where is my 210? So again, if I started standard position, so I start here, and I go around, and I go around, and I go around to 210, that's right about here. And in fact, it also shares that 30-degree reference angle, because I am now 30 degrees past 180 to get to 210. And notice what my adjacent side is. Again, the adjacent side is 0.866. It's negative 0.866 because x is negative. And my radius, or my hypotenuse right here, is still 1. And I get a cosine ratio that's negative. Oops, I meant to change this one. This one, I got the wrong one right here. This is supposed to be, let me fix this. This on the original, I think, said negative 30. Let's try that. Okay, so now we're going to try a negative angle and see what we get. Okay, so I'm going to erase this a little bit because it's getting a little bit messy. And then we'll start over. Boom, there we go. Okay, so we're still on our unit circle. Things we still know. Okay, so what's going to happen when I do, negative 30, I'm not going to go that way. I'm actually going to go this way. Right, and that takes me right here. And again, that has a 30-degree reference angle right there. And we said before this is 0.866 to 1 in the 30-degree angle. Well, it's still going to be 0.866 to 1 on our negative 30-degree angle. So a negative 30-degree angle has a 30-degree reference angle, and I get the same cosine ratio. Hopefully you can see that I would get the same sine ratio as well. We might take a look at that in another video. This one's getting a little bit long. So for any angle in standard position, the cosine and sine of that angle are the same size as the cosine and sine of the reference angle. Okay, so when I come back here, and I could throw in my other triangles just to see really quickly. Right, we had this one here at 150, but it had the same reference. Right, this though was negative here. So the cosines are the same size because when you draw the picture with the same angle, you're going to get the same ratios. Sines are going to be the same. Also, this opposite side is going to be the same size as this opposite side, is going to be the same size as this opposite side, and as this opposite side. What we have to worry about is whether they're positive or negative. So, and that's what the second part of this says. So they're the same size as the cosine and sine for that reference angle, and then we figure out whether the ratio is positive or negative by looking at what quadrant our terminal side is in and whether the x is positive or negative there. So we're going to continue with this in a little bit in the next video.